Good morning. We're ready to continue. I have prepared my notebook, so I'm ready to talk. I will tell some words about informational equilibrium and informational structure, and I will show some software that have been written maybe 5 or 10 years ago by me. Maybe it will give a basic idea how the structure may look like, and then we will discuss your progress. Uh, okay, so I will start with sharing my screen. First of all, I would like to show an article again. It's a Nash Equilibrium. So the games that we are working on are location games or paranoid games, many different names depending on what exact conditions of these games we have, but they usually work with certain situation. They don't have uncertainties. So the idea of paranoid games, it's very funny thing. My friends, colleagues, they shared with me one interesting idea. So as you know, what is a Voronoi diagram? So I almost sure that you know, but I would like to be sure. I have a picture. So it's like this one, Voronoi diagram. And people, what do? They got a video recording of a sport match, for example, basketball um, or football, but they use basketball, and we can place uh, players there. There is a basket here, and we can create Voronoi diagrams for these players. So it's just human. Here, it will look like here or something. So if there is another player, this one. And in this case, we might want to try to check the area of this situation like a control area. So so this guy, he some kind of control this part, because he will be the first one who can get the ball if ball gets in this area, because of the definition of this diagram. He's the fast. He has the shortest distance here. Of course, it depends on his velocity and other things, but in general, it looks like he will be the first one. So he controls all this idea, and then during the game, this area is changed, and some coaches, they consider such diagrams and some statistics and analytics of this useful for creating programs for the players. It's some kind of logistics, but it's not real one. Well, it's not the usual one, because we usually think about logistics as cars, maybe, or airplanes. But here we have logistics of just balls and players. But we can easily generalize this situation for military purposes or many others. So we just control. Okay, and there is a Voronoi diagram, and we might want to think about well, it's not about graphs; it's about just planes to this situation. And here we might want to talk about 2D situation. People, well, there are models, theoretical models, that try to describe city just as a circle. Well, it's like a Moscow, so they think that it's almost universe. Well, now we know that Moscow is not of this shape, but of this shape. But before that, they consider it as well, many cities, they have a shape of sphere or something. Okay, and they try to think about shops here. Well, it's not so good because we know about metro stations and other things, but for cars, if you have roads, maybe not so different there. So maybe it's a good model, but of course it's very, very theoretical one, abstract one. Okay, and for another diagram, we might think about game equilibrium. For example, if we know that this situation is here, so the shops, we control this area, what is the best variant for next player to place his shop here? Where? Where should he place it? So the idea is that then when he places it, like here, then the diagram will change, and he will get his area. But for what point this area will have its maximum? It's not so easy to suggest. I'm not sure that for any given set of points you will easily find without any computer, and even with computer, because we talk about geometrical things. So we need to check all variants. So there is infinitely many points here. Oh, there's many points, and it's not very easy to find it. It's a good idea, and there are some results already known in conferences and articles. So if you're interested, you want to check it. And of course, there are many things about uncertainties. So maybe we will talk about it in the fourth model to generalize our situation with graphs. But right now, we just skip this, and we'll talk about it as an additional chapter for our lectures. So uncertainty here. So if there is an agent or no, so maybe this player, he doesn't know where, if there is a shop or maybe there is no shops. For example, he knows that there is a shop, but his owner, he has some plans to close the shop. So there is uncertainty. And here, we might think that there are two players. So there are several players that already place their shops, and we have two players that play, and they have uncertainty. So this one is a friend of this owner. This player has some other information, and they have playing, and so on. Everything what we have done before for graphs, or we plan to do for graphs. We have to do with planes. It's like Voronoi games. So Voronoi games is because of the diagram. Location games like here on the network. And there are some solutions here. So by the way, there are many guys who do this. For this one, as I remember, he is and this one are Nobel Prize winners, or at least very, very famous guys. And they have structures, very simple structure. And but they have for these simple structures, or almost simple structures, some theorems that we don't do right now. So we do just calculations, but they have theorems for this. If you will have enough experience, we might want to prove some theorems as well, but it's not necessary. Okay. Okay, so this is about some survey results that might be connected to our topic. But about our game. So I have created many years ago an example for students, for myself to understand the situation better. It was known already, so it's not a very new from a mathematical point. It was just a good example for training. Here, okay, yeah, I think you can see this screen. If no, then let me know. It was written, I wrote it in MATLAB, no, it's MATLAB, in JavaScript, this one, and maybe in several other languages, I don't remember. But in JavaScript, it looks like an interesting thing. So here we have 4 agents, and they have 4 ages somewhere in network. So there is a network, and there are 4 ages somewhere, and we might want to specify which ages are known for every agent. For example, for this agent, he knows state of the first and the third age. This one knows only the first one. This one knows second, third, and fourth. This one knows first, third, and fourth, for example. Okay, we have specified well some specification here, and we can make a structure. Yeah. What it is? So usually I draw these pictures using circles or rectangles. For this picture, there are no such circles and rectangles, but the main idea is the same. So we have true state of the world. So yeah, and we can specify which is the true state. For example, we can specify that this one is true, and we will get a new one. So we have a true state. These 2 ages are under construction, so they are not available for agents. These 2 are available for agents. And we have 4 agents. So in our game right now, we have only 2, but we can imagine that we might want to have 4, and it's a item in our plan that to implement in our code late. So there are 4 players. All of them think that this real world is possible. So the idea of this model that they cannot be mistaken. So they have uncertainties, but there is no lie and there is no false beliefs here. Of course, we can consider similar models with false beliefs, but here is no false belief. So he, well, agents they doesn't believe in false, but they just maybe have no enough information to make a decision. So this is an idea. Maybe later I will talk about logical. From the mathematical point of view, there are axioms, system of axioms, S5, KD for 5 systems, but it's not necessary for us right now. Maybe it will be late. So for agents, but every agent has his own uncertainty. For example, this guy, he consider not only this world as possible, but also these ones too. So there is ages. This for the second, this one, and so on. And for the third agent, only one possible, only this one, and only one more possible bond than this one. So it's a this list here. It's like a coding of graph. So we can imagine large graph with million vertices, but uncertainty only for the 4 ages. For every such world, we can imagine an agent that he is uncertain about all this, and so on. So we can create this sequence of worlds and agents. We can count how many worlds we should have. It's very easy. And agents, it's like an exercise here. But to find an equilibrium, we need variables and we need utility functions for all. Well, we need utility functions for all these worlds. So it's here, and we know how many. 2 in the power of power of 4. Wait a minute. Power, yeah, 2 in the power of 4. So it's 16 here. I think that should be 16 once. Okay, and oh yeah, 16. It's not necessary, but because we are attached to the real true states, and for example, if they all of them knows, for example, the fourth age, like here, that there is no 0000 age. So they definitely know all of them that an age number 4 is available. So the world 000 cannot be treated as possible here. So it's like a connected component of the whole graph. Okay. Well, let's see this one. It's slightly easier than previous one. And we have a matrix utility functions for this. So if we are given exact now certain actions or certain strategies for these agents, we can find the utility functions for all of these agents, and so for every other worlds. So in this, so we can construct U1, U2, U3, U4 here, and for every possible world here. Okay, we can. Oh, so it's 2 to the power of 4 here. Matrices, and we have real agents. It's variables for us. So in our equilibrium, we will have solution for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or so maybe. I have mistaken, but it looks like it's really 12 versions. So our solution, our equilibrium, will provide us with values, maybe several combinations of equilibriums here. Of course, what we really need is these numbers. So if our system of equations gives us an opportunity to solve and to find these variables without finding these ones, it's okay, that's great. But maybe not. And universal, general method of finding it will require from us to get equilibrium with all these variables. Okay, and for every these variables, for example, so we have only 4 agents. I would like to focus on this, that we have 4 agents, but we have several phantom agents. So when I think that it might be that the student has property, or maybe he doesn't have this property, so it looks like in my imagination there are 2 variants of one student, and I should I should try to predict his actions in both cases. And student, he might be uncertain about teacher, and he has to predict his actions. So it's like an imaginary things. But as for imaginary and for real ones, people, they do the same manipulations in their minds. So it's some kind of doesn't matter here. Okay, so we can find this, and for every this point, what we should find, we check equilibriums. So there are many ways how we can want to find an equilibrium, because it's very hard work. But I can suggest a very direct way. So we'll try to find only equilibriums in pure strategies. It means that agents are not allowed to use probability strategies, like let it be with, I will use this strategy with the probability 0.3, and this strategy with the probability 0.7, and so on. No. He has to choose one strategy for all the cases. So pure strategies. It is known that in some cases we don't have such Nash equilibriums, but sometimes we have, and we will try to find them. So the idea is that we just check every possible variance. So we assign here for every variable here, we need many versions. I mean, many variants here. So we should check all combinations of actions. So it looks like if you have 12, so it's 2 in the power of 12. But it's still not very large, so it's just maybe 2 in the power of 10 is about 1,000. So in the power of 12 is just 4,000. So it's okay. It's reasonable, if I'm not mistaken. Yeah, it looks like 4,000 variance here for this specific case, and we have 4 agents here. So for agents, 4,000 cases. It's okay. Oh, no. 4,000. Wait a minute. Yeah, 4,000. Yeah. So, but if they have to choose only 2 variants, of course, if they're allowed to choose more locations, like 3 locations or 4, they will need to find much more number of variants. So it's like if each of them has k opportunities, so we should get k in the power of 12, many of them. But we can reduce complexity of our task to just several versions. So we can allow for many agents just only 2 or 3 possible spots. It's okay. Why not? Okay. So and what is that? The condition of Nash equilibrium is that every agent, imaginary or real, he doesn't want to change his action if others chose their actions. So, for example, for this first agent, he has to check. So, if these guys have already made their choices, then he want to check. Does he want to change his strategy? So we can check it by his metrics. Is in this matrix his action is best one, or maybe not? Okay, if it is best one here, then we can say that it's okay, and here as well. But sometimes, but here we have 4 different matrices, so it's not usual Nash equilibrium. What should we do? I have suggested 2 variants. The first variant is just average sum, so he get a new matrix that is an average of these 4, depending on the probabilities of the states. It's like I don't know, bias and Nash equilibrium. But for example, he might want to take the same probabilities for all these worlds. So in this case, he just gets the usual average. But maybe he wants to get like an arg maximum. So he wants to be sure that in the worst case, he will get his best. So in this case, we get his minimum. So he tries to find an optimal solution, considering that others will do the worst for him. It's like a maximin here. So, for example, if he plays here, he can choose the first spot, and he has great profit here in this world. But in this world, he will have a great loss. Then maybe he doesn't want to choose the strategy because he is afraid of this loss. And there is another strategy that have average profit here and average profit here, And in this case, he might want to choose this average strategy. So it's not so good as for this world, but it's not so bad for this one. In this case, he might be satisfied with this strategy. And this is another way. So we get just a minimum of this situation. It's like a Maximin's approach to this solution. For this specific task, Maximin solution is more natural because we don't have to assign probabilities here. There is no probability error here right now. So we can stay in this model without probability error. So Maximin is okay. But we might want to get probabilities here, no problem. Okay, can check. I can send you this software. There is no problem. It's not very efficient, and if you look at this code, because in JavaScript you can do this, it's not something very secret here. I don't remember. It was long time ago, so I don't remember how to see this code. But you can do this. It's very easy. Okay. So we have discussed this one, and we have discussed that one, and we have code, or just my some code that was to help you to create your own code. Okay, maybe we have discussed all what I have prepared for today before we discuss your status. Right now in working on your homework and project. If you have any question, please ask me. I will try to answer your questions. Okay, we continue. So I would like to recall our plan for our homework for both models and for our project for the fourth model. So it's like a task list here. We have created Nash equilibrium, we constructed utility matrix, so you can get all this information in previous lectures. We have recordings, so I don't think that we need to just repeat it again. Though I find new students, that's great. I hope that you will have time to work on videos that we have, and you will have access to these videos if you are in our chat in Telegram. So we were here, it's old, but now we are not here. So we are like here maybe somewhere, or maybe even here right now. We will discuss it. Okay, and we try what's in the third model. In this one, we will not have enough time to create all these tasks to finish them because there are many things, and we have only 5 days before the session time. So in this case, in this situation, well, exams. So I don't think that is very easy to make all these steps. We will continue in the fourth model with these steps and project investigations and so on. So I think that if today we will finish at least in the first maybe approximation our informational structure and try to find Nash equilibrium, it will be great. Okay, I think that no questions right now. I will start from Ilya, for example. Ilya, what is your progress right now? Where are you at these steps? So what you have developed already?
I have informational structure, but I need to write the Nash equilibrium for all agents.
Okay, I understand. But is your plan is clear for you? Do you understand how you will write this? or you have any problems with theoretical?
Yes, I think I do.
Okay, nice. Okay, okay. So today you will have time to work on this. I hope you have Python or and other things on your computer. Okay. Um, I'm not sure that I am able to pronounce in the correct way the name of the second student,
Ishita.
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 Okay, great. So I think I never saw it before, or maybe.
No, I was here before. I missed
Okay.
last three lessons because I was
Okay.
sick.
Okay.
But before that I was here. Yeah.
Okay, great. I'm happy about this because I worried that I should to repeat everything that I have.
No.
Okay,
I
great.
saw the materials on YouTube and I watched the lectures,
Okay,
previous ones.
great, fantastic. So, have you tried to write a code about this?
Yes, I have checked the Jupyter notebook and I've been trying to complete these tasks for
Mhm.
the past few weeks. So
Uh-huh.
I think I will try to complete this, and if I have any questions, I will let you know. I will ask you.
Okay, that's great. About your
I
code,
think one more question. I think we have time till end of the semester, right?
we have
To
time. Uh-huh. Yeah,
we have yeah, you're gone.
we have we have two models, two parts. So we have the third one and the fourth. So
Yeah.
you will have time to do this.
Yeah. The question is, we have time to hand over the homeworks till the end of the semester, right? So we have another module, right? Another module we have.
Uh
Now we are doing in the third module, and we have another module is the fourth module, right?
yeah,
So in April we will start the fourth module.
yeah,
Okay, so end of this fourth module, we need to hand over the homeworks, right? So we will complete the homework and the project, and we will hand over it to you in the end of the I think May, right? Around May or
yeah,
June.
yeah. May.
So we have time, right? It's not in
Yeah,
a hurry, right?
yeah. But there are a lot of work, so it's better to be prepared for May, to
Mhm.
have time in May and in late April for other courses, because you will not be able to work hard on this course if you have other courses as well. So you'll have many
Yeah.
exams.
We have many courses. Yeah.
Yeah, so I think that maybe it's wise to start working as you do. So
Yeah. To finish early, right?
yeah, that's okay.
Okay.
Uh,
Can I ask extra question?
yeah, please.
What we're gonna have for the exams? Do we gonna have some kind of exam paper, or we gonna have some kind of MCQ questions to select answers or something like that? What is the format of the exam? Or do we gonna have? Can we? Is there any possibility to skip the exam if we complete the homeworks and the project? How is gonna work for the exams?
Okay, I see. I'm not
Because
sure about.
I
Mhm.
know that in other subjects, usually if we complete the homeworks and the project, they will give you the full marks and we can
Yeah,
skip the exams, right?
yeah. I know. No, yeah, I know. It's a good practice. Well, uh, I can tell about the fourth model. I'm not sure about marks at the end of the third model. I maybe should check it.
Okay.
Do-
In the third module, we don't have any exams. We don't
Okay,
have
okay,
yeah.
great. Because I don't remember this information from our educational offices. Okay,
We don't have any
okay,
exams in
that's
third
great.
module.
That's great. So we will have only to put marks on the fourth model. Okay, nice. So yeah, I think that if everything will be clear in with homeworks and projects, maybe there is no exams. So here,
Okay.
at least I see how Ilya work hard during every seminar. So I think that it's very easy for me from the ethical point to give him highest mark because he's very successful.
Yeah, of course, yeah.
Yeah, so I'm not worried about him, at least now. I'm not. I
Mhm.
don't know his future work, but right now he work hard. Yeah, uh, but maybe if not, but yeah, if you will not succeed in homework and in project, well,
Mhm.
then maybe we will need an exam in a special situation.
Okay.
Yeah, okay. And for project, I think that it will be a great idea to create some kind of presentation and maybe try to write an article. Not an article for a journal because it's additional work, but it will look like a journal. For example, we tried with your colleagues, with the students of the third course of the third year. So from bachelor um, courses. So and they have created it. It's not a complete article, but it was like a preliminary part for science. Scientific journal science. We have downloaded their
Mm-hmm.
template. And these guys, they're from the business department, they're in the logistics groups. They have created some kind of investigation and research how they use genetic algorithm for their
Mm-hmm.
specific problems in logistics. We have discussed it during that model and so on. And many of them, they have created such a file and in a very universal model. And they have graphics there, so they will have learning of the genetic algorithm. It was rather funny thing.
Mm-hmm.
So I think that it would be great that, for example, if you have some kind of article that is so preliminary article with some code, maybe like here with some discussion, and then some investigation of real works, real networks, like a traffic in London, for example. What we can say about traffic in London from the game theory point, and we create and we can describe the settings of this in a formal model. Then you show some code maybe, and then you will show graphs and Nash equilibriums and many other things that you will have to get here. You will have software by that time, and you will have some numerical solutions. You will show it in diagrams, maybe maybe you prove some theorems even, but it's not required. Just some diagrams, and and that's all. It will look like an article, some data analysis, data science of such traffic, or some logistics. Of course, still very abstract and theoretical things. It's about game theory and so on. So it's not. It will be it's very abstract, but it will be maybe good theory for this situation. Uh, yeah. Okay.
So basically, we can take a paper from any journals, right? And we can read this paper, right? And then we can do some presentation on this paper and some implementation and the experiments, something like that. As
No,
I go.
no. Well, we can get a template, a decoration, but
Yeah.
we don't need. Well, you can, but it's not necessary to read additional articles about this. So
Mm-hmm.
I know that there is a way how people work. So they download article and they make a presentation about this article. It's great
Mm-hmm.
scientific way of understanding what people are doing. So that's great. But I don't think that it's our way for this course. Maybe we will avoid this discussion of these articles. Mm,
Mm-hmm.
we will just
So so
yeah.
my question is, how to select the topic? How to select the topic for the
Okay.
project?
Okay. Yeah, we will talk. So the idea of for this we have discussed. So I provided some data sets for Ilya, for Emmanuel. It's a Colorado University. As I remember, there are
Yeah.
many networks there,
Mm-hmm.
and you can choose your network there. So, for example, it's traffic in London or roads in Birmingham or maybe some other things, and you will adapt it to your software, and your topic will be just game theoretical analysis of
Mm-hmm.
situation or logistics in this city or in this country or in this state of United States and so on. So the topic is just a name of database maybe, and maybe some ideas of this.
Okay, so basically the idea is we take the data set and we will implement some theory which we learned in our lectures, right? And we will do some
Yes,
program from that, right? Okay, okay, now I got it. Now I got it. Yeah.
Okay, okay, that's great. In this homework, we have very simplified version, so we don't use many theorems from our theoretical part from our first lectures. But if you will be strong enough and if you have enough time, we will be very successful. Then in the fourth model, we can apply many theorems from our theoretical part, when we have submodular functions and so on and so on. Uh, brands and bounds algorithm and so on. But right now we have very simplified thing, but it will be still a very interesting thing. So I think that we will try to put as many theory as we will be able in our work. So our project will look like a great interesting result. So that was the idea. So, and there is a part of theory that is required, and then we will add as much theory as we will be able from the first lecture. But the main idea, yeah, you got it right. So we will use theory for this software. Yeah, that's correct.
Okay, thank you.
Nice. Okay, and Ishita, where are you in this code? So in these steps. So have you already implemented Nash equilibrium algorithm, or maybe a graph to game transition?
So I have tried the first 3 points, but
Okay,
still I need some time to complete the rest because
okay, I
I
see.
didn't have much time to do
Yeah,
the rest.
okay.
But I will do it. I will try my best to complete before the end of the semester to complete all
Okay.
the steps.
Uh, all these steps
I
in
mean,
this
like till the end of the homework before the end of the semester.
the third or the fourth.
Yeah, because we need to do it, right? No, I
Right.
mean not the fourth. I mean like till the 14th point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? We
Okay.
have how many?
I think that it's very a difficult task to do all these points in the third semester, because we have to end it in a week. So it will be very hard thing, but it's the problem for fourth model. So
Mm-hmm.
for this case, I think it's possible and okay. But I doubt if it is a very easy task to do this. Well, of course, if you are experienced and, for example, if you have enough time and because we don't know each other uh, experience, maybe you have a great experience and maybe you can code this just using one evening, so you will sit in, somewhere in a good place and write it down into hours. I think it's possible, but it's very
So how many numbers we need to finish in third module? So as
well.
example from here
uh okay,
for the third module.
yeah, okay, I can say. So now with Ilya we are like here here, or maybe
So
develop.
basically half, right? We need to complete half in
I think like
the third
here,
module, right?
I think
Maybe 10. Okay.
here, and maybe here. For several shops, uh, we will don't we won't have enough time. So maybe 11. I think that 11 is a good number for the third model,
Mm-hmm.
because for Ilya we are almost here. So he has to implement Nash equilibrium is here, and it is done. So it's just a work of one. Maybe today he will finish this one. Uh,
Okay.
we will have to we will need to talk with Emmanuel about this work, but maybe he will succeed with this too. It's okay. We have 1 week. It's possible, but it will be hard work. So if you succeed with 11, it will be great. It will be fantastic. I would like to say.
I will try. I will try to catch up.
Okay, that's great. I will try to help. So if you need any help, you can try to ask for this. Okay, so if you have any questions about these three or and others steps, let me know. But I think that you know what to do, so you have a plan. So you need just time to implement these ideas to these items. Is it correct? Ishita?
Yes.
Okay.
Yes. Yes. Yes.
Okay, great. Okay, so Ilya, Ishita, you can start your your work right now and work on what maybe you already do this uh, with this code, and we will discuss your result maybe in half and maybe an hour if you uh, don't finish this before that time, and then uh, we can discuss with Emmanuel his progress. So, Emmanuel, what is your progress? So you told me that you had hard work of trying to implement this code. What successful? So, what have you implemented? Emmanuel, are you here? Emmanuel, okay. Um, it's okay. I will tip. Maybe not tip. Yeah, I will ask. Okay, I have some kind of conversation. I'll check what is conversation here. Unfortunately, my pick. Oh, okay, I see. Yeah. I understand because PC and many other things in our world is not safe, not safe. It's not ideal things. There are mistakes and other things. For example, my own computer he broke last lecture, and I had to repair this. So I understand this problem. And even today, he had some problems with Windows update. But I have restarted, rebooted my software, and that will be great. But there were problems with Microsoft updates these days. I don't know why. They have some critical problems with printers or somewhere. Oh, okay. Email. Okay, that's great. Okay, but Emmanuel, do you know what to do? So, do you have a plan, uh, or you have any theoretical problems with working on the software? Do you know what to do? Do you know how to create informational structure and so on Equilibrium? Okay, I suggest that maybe you have all the information you need. So if you don't have any information, for example, you forgot what the Nash equilibrium is, or you forgot what is Pareto optimal things, or maybe what is informational structure is, and so on. So of course there are books, there are sites about this. So it's not something very new, though the combination of these topics looks like very fresh and new, but all these topics uh, just separately, they're well known for maybe decades and maybe even 100 years. Okay, great. So all of you have now a plan what to do. You have no obstacles that could prevent you from doing it. Well, I understand about PC problem. Yeah, that's okay. Okay. So what is more? Okay. Okay. Yeah, it's okay. You can send me by Telegram and so on. But I would like to show you an opportunity. So, for example, when I was, I would like to share my experience. I was in Amsterdam, in Netherlands, and I went there for conference. I had a talk there, and I found that there is an opportunity to attend the lectures of Haskell. It's a programming language. The one PhD student, he, like postdoc, he was on the age between PhD students and postdocs guys. So he prepared lectures for master students, and he gave this course. And I decided to attend it because he was very experienced and so on. But I didn't have a computer there in Amsterdam, so I had only my phone, and that's all. and they didn't have a computer class. Well, they had a computer class in Amsterdam University, but they didn't have them in this specific. It's the Institute of Logical Linguistics and Computer Science or Informatics. I don't remember. It's a part of Amsterdam University. So every students, they had their own computers. I had no, because I had only to give a talk, and I made these homeworks using just phones, because you have in internet now opportunity to compile your code in the online compilers. So you can just go to this site, I will show you, and you can compile your code even using your phone. Of course, it was difficult for me to make very sophisticated problems during this course, but first 3 or maybe 4 lectures, it was great. So this online compiler in my smartphone was enough to make all these exercises for Haskell. Okay, so I will show you just to make sure that you will have. But of course, I understand that sometimes you have no opportunity even with your phone for any purpose. That's okay. Though I suggest that for lectures and for seminars, you will have some time to work with them. So, for example, you can use, if you talk about, okay, it's for Haskell, collab Python. There is a great Google thing, like here.
Yeah, I know.
Yeah, and you can get access from any computer there if you have a.
Yeah, of course, yeah. Here, the reason is here I don't have my personal computer, but I have the working computer, so I can use the working computer, and I will try something.
Okay. Okay. I sent this code. It is my version of this code to Telegram, so you can use it. Maybe you already have it, or you can download it from Telegram chat, because it is available right now. Yeah, sorry, it's in French. I'm trying to learn French. Okay. Okay. Yeah. Okay. That's great. So you know what to do. Then maybe we will discuss a very simple problem. It's like a test program for equilibrium, but a bit later, maybe about 12 o'clock or maybe 11 and a half. So now please work on your code, and we will discuss your progress maybe at 11, or before that, if you will succeed very fast. So we can discuss your progress before that, and problems. If you get some problems, let me know. So, but if not, then 11 maybe, and 11 at the quarter. Or we'll have like a break. We should have a break from 10:50 to 11:10. So okay, then we will discuss at 11. Sorry, at 11 maybe 20. I think it's okay. So you will have about 25 minutes before the break, then you will have break, and 10 minutes after the break. So it's half an hour. I think it's enough to show some things. Okay, so 11, 12, 20, and I'm here online, so we can contact. Okay, we can continue. I understand that maybe half an hour is not enough to create all this code, but we can mm, discuss if we have something to talk about. So, if anyone uh, created the code, oh, I see only Ilya. Okay, Ilya, what is your progress? Have you developed a code?
I didn't finish yet. I
Okay,
was a bit
okay,
distracted.
okay. Ishita, have you developed some code? Maybe have already created something?
Nope, not yet.
Okay.
I was looking for a data set, and I
Yeah,
think
yeah,
I
yeah.
found it.
Yeah,
And
it's understood. Okay, okay.
Can you please again tell how the equilibrium on informational structure work? So all these imaginary players, they are playing on different graphs. So what is the game?
Okay. I think that we can use the game that we have tried before. So it's just a graph, and they have customers somewhere in the graph. And for example, if we place here at U, at here Y, then U will, well, we can say that it's like the the sum of closest customers. Here, this one is a profit for U, and this one is profit for Y. This kind of utility. So we count number with weights of vertices that are closer to this specific shop on the graph. This is the game.
Okay, but
Yes.
Mm, but how do we compare, no, find utilities for different imaginary players? They are all playing on different graphs.
Okay. I can say okay. For example, let me have several graphs. This one, the first one. Then we have. Well, we need here players. So first player. For example, second one. Well, maybe here we have another graph. Here we have such graph. For example, such kind of graphs. And then this, in this case, we can use backpropagation scheme to find an equilibrium. So we should find for player one what is the best thing. So it's there, equal here and here, and let me check what is the utility function then. Let's calculate utility function for some specific actions. So I will use, for example, green for one. Yeah, and I will deny situation when they both has the same spot for shops. Oh, yeah, sorry, I should place here. Yeah, almost. So the set of nodes is the same for all graphs. The problems with ages only. So this will be for green. Well, maybe not this green. Yeah, red for. Sorry, wait a minute. I will have okay nodes here. We're not in a hurry, so we can nodes. Then it will be green for first one and red for second one. In this game, for example, it may be that this player he chose this one, and the red one use this one. Here, well, since the second player he choose this one, he has to choose this in this situation as well. They have to be the same. This one he might want to choose this situation here, and it should be the same here. Okay. What about red? Red might want to have it here, but it has to have the same here. And one, for example, here. What about utilities? Okay, let's check. Here we have this one for no one, this place. Here, well, we think that, well, we can um, assign values this once, 1,000 of customers at each spot. In this case, this guy will have 1.5 because they have to split this situation, and this one is for no one. So it's even not their a zero-sum game even here, because we have a spot with customers who are not satisfied at all, and they have no opportunity to go to this guy. So given the situation, I'm not sure that we have. Well, I think that maybe in our test examples we had not tested the situation, so it's not uh, easy to check. I think it's great if we consider these customers they are not connected at all. So they both players they lose these customers. So for our algorithm, we should check that uh, there is no connection. So it's like infinite uh, the distance. So we shouldn't check minimum or maximum. We should just eliminate these customers from consideration. Uh, I'm sure that in my code there was no such exception. So maybe I should upgrade it. And you, if you didn't think about this, maybe you should upgrade this. Okay, so uh, 1.5, 1.5. What about here? Well, here we have only half for the second, and we have um, and two, not half. Sorry, it has the full one. So this one is red, and this one will be green. Here, what about here? So green will have only one, and red will have two. But here, green will have one, 2.5 of this. So 2.5, and red will have only uh, 1.5 here. And we can assign now this sorry, values to this agents, to this one, for this agent, for this, and maybe this one for this. But we don't know which world is correct right now. So this one, for this one, like here. It's an imaginary thing, so, but it's not. It's like a decision making, so we don't know. So they have to choose what to do, and they have to uh, make a decision here. But here, let's we think that we talk about maximin here situation. In this case, we should check 1.5 and 1. So 1. So the worst situation for the second player if this case is real. So for him, minimum is 1. For this guy, imaginary, 1.5. For 1, here we have 2 and 1 equals 1. Here just 1.5. and that's all. Yeah, and if they have if they have not max-min situation, but probabilities. For example, we know that probability of this P1, P2. Well, indeed, this probabilities is not assigned to the to this world, but they should be assigned to this age, because, for example, this guy he might think that this world is very probable, and this one may think that it's not. So, indeed, these numbers should be placed here. Maybe I should do this. So, here. So we have P1 here, 2. I just have direct enumeration here. We have some restrictions. So P1 equals 1. It's just because we have, well, the sergeant considers only one world, so it means that its probability equals 1, no other worlds. So here P2 plus P3 equals 1, P4 plus 1. And of course, all of them are larger than 0. And independent, not here. They not each pi larger than or equal to 0. So if we have such probabilities here, we can calculate their payoffs here, expected payoffs. So it's paid in for this guy. Okay, it's okay. Here we have 1.5 P2 plus 1 P3. This is their utility for this imaginary one. For this guy, we have 2P2 plus P5. Here we have 2P6 plus P7, 1.5. Yeah, and here we have just 2.5. Okay, and there are ways how we should calculate utilities. So the greens and reds here, minimum, is the max-min approach, and blue are bias approach when we know probabilities. Is it clear right now for utilities?
Yes.
Okay.
But again, if we have, for example,
Mhm.
a player which doesn't know about one age,
Mhm.
how
Okay.
many players we will have for him?
It depends on how many other players do we have. For
Okay,
example,
we have 2 players, each one doesn't know about one age.
okay, great. Let's check. So we have one age, have another age, and one is observed by the first player, another is observed by the second player. Is it correct? Yeah. How many variants and how many imaginary players do we need? Okay, we can use some kind of logic, and we can say that E1 here is true if there is such age, no, and not E1 if there is no such age, and C or phi2 if there is if exist, and if there is no such age. And so how many worlds do we have? Well, we have P1, P2, have P1 and not P2. We have not P1, not P2. And we have P1, not P1. So we have only 4 variants for possible worlds. So graphs, as we have created a code before, so we can now using an algorithm get from this one. So there is a function that returns a graph having these parameters phi1 and phi2 of heroes. For each combination, we have a graph. So there is a graph here, graph here, here, and here. So the first one, he knows phi1 definitely. So, and second one, what is the idea that for this player, the second one, these things that he can observe are the same. We can think let phi is well, phi is not a good thing, like w of the graph is what they can observe there. For example, here the first player can observe only one if it exists, and 0 if it doesn't exist. And the same like observation function. If we have something more difficult here, we have such graph of age, such a list of ages 1, 2, 3, 4, 5, 6, 7, 7. And for example, the first player, he does know this and this, and maybe this. Okay. In this case, if he has no other information, he what he can observe? He can observe this one, this one, this one, this one, and he have for these things so he cannot distinguish here 0 from 1 and so on. But the agent, so if an agent observes this one, for example, he observes 1, 1, 1, 0, as it is here. All possible worlds that are just differs from this one by these 3 parameters are indistinguishable for this player. So it's 2 in the power of 3 indistinguishable graphs for this specific one. But how many such agents do we need? So, okay, if we don't care about what is the real world, because maybe we want to construct, well, in my model, it is one only one connected component there. A JavaScript example, but we can consider a universal one when we pay no attention to connectivity of this graph. It's okay, no problem. And if we don't pay attention to connectivity graph, in this case, we will have to check. So, and here we can check another one. For example, here 0, 1, 1, 0. So the difference. And again, 2 in the power of 3 variance. So we we are able to vary these three letters, three numbers, but these 4 have to be the same for this agent because it's his observation. So how many agents do we need? Okay, it's just the number of different observations here. So it's 2 in the power of 4 here. In general, what we might say that if we have k ages as a sum, well, just k ages, agents, they have some subsets, like k is a set, and we have k number of elements in k, and they have some k1, k2, and k3. It's just subsets of k of a larger set. And then a number of agents for every such a set is 2 in the power of ki. And each such agent has the number of distinguishable worlds or graph for them that is equal to this one. And we can construct, if we need this graph, in a direct procedure. So let's imagine that we have just listed all possible variants of this k ages. 0, 0, 0, 0, 1, and so on. So we have many variants, like 2 in the k variants. And then we might want to apply these observation functions here for every agent, here for 3 agents. For 3 agents. And there are some, it's not numbers, it's like filters. So for example, we might have here this vector, here we might have another vector, maybe the same, here maybe only this one, and here maybe at all nothing, so he cannot see. So just empty set. Okay, we can do this. We just like a Excel table. So we just take as digits from these vaults. Okay, what now we can do? Okay, all what we need for graph. Our graph will have vertices for walls. It's just 2 in the power of k. Okay, and we have nodes. The number of agents of each agent is just the number of different values here. It's like we have a set of this list here, and we get his size. Oh, any other variance, how you can calculate a number of different elements here, and for everything. So here you have here. It's because we have all possible variants. In real situation, or more real situation, we might want to exclude several variants by just public announcement. In this case, they will have less number of worlds here, and maybe we need less number of engines. It's okay, but now we look at this as just situation when we have the largest informational structure. Then, if we have a public announcement, like I told, for example, this situation is definitely not because we have read it in newspaper. So in this case, we just take our large graph and eliminate some nodes. No problem. So the problem is to create the largest graph. Okay, and okay, so we have nodes here, we have nodes here. And for our graph, we need to get edges, not in our graph. So we have logistics graph, and this graph of informational structure. Okay. So a graph of our logistics is just like a traffic, or a map of London, or Birmingham, or Tokyo. This one is not. It's just imaginary thing in cognition of these guys. So they're different things, and it's not easy to say which one is larger. So so we have here this one. We need ages, but ages is this situation. So we say that this so is a bipartite graph. So bipartite graph. So in one part we have only worlds or graphs possible, and other we have possible agents. If we talk about one agent, if we have several agents, we have like several. It's like a product, direct product of bipartite graphs. But okay, we construct just for one, and then we will construct for others. But we can construct even simultaneously for all of them. So we connect. So we have graphs, agents, possible variants of the first agent, possible variants of the second agents, and so on. And now we need ages. Okay, we take one node here, and we want to connect them to all these agents who are well, not for one. Well, I said the one node for an agent. We connected to that agent, which observation function is equal. Well, which equals this observation. For example, here and here. The second one, here he has another observation, so we have to connect it to another nodes. But this one, he has the same observation function as here. So this one we connect to this one, to 0, 0, to 1, 0, and so on. And this algorithm returns exactly the informational structure of our graph. Is this thing clear? Yeah.
Yes.
Okay.
So we have one imaginary agent for every possible observation
of this agent. Yeah.
Okay, but when why do we need that? We already know what is observation.
Yeah, that's right. We know, but others agents they they don't know, and they have to think about this agent. For example, I go to this. Well, there is funny example in one French lecture that I have watched maybe 2 days ago. They showed situation when there are two cars. It's a car. This car. And what we don't know, they just one parameter. The parameter is where are they? Well, they are in the country, and are these roads from they are right-sided or left-sided? Well, maybe they have another example, but I took their idea to this example. For example, we don't know if this guy he knows that in this country it is allowed to go to in this situation. Maybe he thinks that For example, he might think that it's only one-way road, or maybe two-way roads. Maybe it's even simpler. So if he thinks that it's only in one situation, then he might think that he want to go here as well, and this one he is wrong. He shouldn't go in this situation, but he has to think about this guy. What will he do? So what does he think about this road? And they might have a problem here because they have different understanding on what are rules for these roads and what are thinking about these roads. When we try to find an equilibrium, we have to consider my opponent, what his response to my to my action. So this imaginary thing is like a chess. For example, if we play football and we want to shot a ball there, we should check. Oh, goalkeeper. He has two strategies. One strategy for this situation: if I will shoot here, he will jump here. If I shoot here, he will jump here. So he has to have two different types of me, or two different kinds of me. Those who will kick here and here, and he doesn't know what will be the right answer. So he have to be ready for every kick. So here, that's why goalkeeper is usually in the middle of their gate, because he has, it's like a Maximin strategy, because he doesn't know the situation, or it's even Bayesian strategy as well. So we need imaginary thing because we want to model reasoning of agents about other agents when they don't know the correct situation. And it's the fundamental and philosophical thing. It's very important for this model to understand it, why it is required at all. So the idea why we consider agents which are not real, because image of these agents can influence on our actions, on actions of other agents. If someone believes that I am an elephant, he will handle me as an elephant, even if I'm not, and so on. So, but to predict his actions, I have to think, and I have to model his image of me. If this thing is clear, I can't. It's a very important part. So I can try different variants to describe this situation.
I think I understand it now.
Okay.
Thank you.
Yeah, it's a very important thing. So if you need any more clarification, I will spend time for this. It's very important part. Okay, so you have to do something. So you haven't finished yet. Yeah, okay, I understand. So you need more time. Ishita, are you ready to show something?
Actually, no.
Have you found?
Because
Yeah, because.
sorry.
Yeah, you have told, you have started your phrase with because. So, what was?
Yeah, because because I was struggling with the data sets, and I finally found a data set.
Yeah, I understand.
So
And
now I can.
and which one? Can you show database data set?
Yeah. Let me share my screen.
Oh yeah, please. The problem with data sets is that they have different formats. We have discussed with manual.
Yeah.
Yeah, and they have age list, adjacency matrix, and they have many comments there, so it's like a nightmare. So you open every data set, and it's like unique thing. You say, wow, guys, you have standards, why don't you use them? But they have many standards, so unfortunately, yeah.
So I think you can see my screen, right?
Yeah, that's right, I can.
So I finally found this GitHub repo, so where I can download these data sets of cities. And from this place, I found this.
What kind of cities? So it's cities of Europe or in Germany
Let me show you. So these are the cities I can select.
Oh, cool.
So Sydney, Berlin,
Oh, great.
Chicago.
Okay.
So
Is one
there
is
are many cities, so I can select any of these, right?
okay.
So here they have this file format, which is TNTP, I think, some kind of a file format they have used, and also they have included the script to read this data also in this repo. So it is very easy to. I don't want to waste time for reading this file and writing scripts, right? So now I have these cities, so I can select any of these cities, and then already I have this data, so I can read the data. So now I need to work with this data, right?
Well, yeah, but I don't see here the connections between these cities. So you have a city init node 1 or 2, and
Mm-hmm.
I see. Init node initial and term node.
And the temp node is the connection, right? So we
Okay,
go from
from
this node to that node.
okay. So you have edges.
Yeah, so here if I change the city, I will get another city. So I will a little bit explore this data set more, and I will think what is the best data set. So for example, I saw that Chicago, it's a smaller data set, so I will use something like that.
Okay.
So I don't need to do many calculations.
Yeah, that's great. That's good.
Yeah, so this data set, it's very good. I think it's good. Here we have
Yeah,
many
cool.
information.
Yeah, cool. That's great. Nice. And how many nodes do you have in this data set? For example, for Chicago, how many roads there are there? 100, 10,000, million, million maybe too much. 1,000. Do you have such information? I think you should have, like a size of your data set. Ishita, are you here? Uh, Unfortunately, I can't see here. Okay. Okay. Oh, I see. So he has a broken internet connection. Okay. So at this time, I know that he has data set. He has chosen data set to work with. That's great. Okay, I see. So Ishida, I'm glad that you have a data set. You have chosen it. Now you can import it into Network X, for example, or any other library to find utilities for the games when we go to
Yeah.
games. Okay, great. Yeah, great. That's a good step. That's a good thing. Nice. So now you have to create all this stuff about net equilibrium, looking for the net equilibrium, create informational structure, and so on. Okay, nice. Great. Thank you. Thank you. What about Emmanuel? Emmanuel, have you uh, created some code? Have you developed an algorithm? Emmanuel, are you here? Okay, maybe he's just a little bit busy. AFK in games. Okay, no problem. Ilya is working on. We have just discussed informational structure. Okay, I see. Okay, so everyone knows what to do. That's great. you have different you are on different steps. That's okay. That's okay. We understand that this course is sorry. Okay, okay. Yeah. Manuel, that's a good idea to find a network there. Okay. But if you
Can
yeah. Yeah, Shita. Yeah.
okay, go on. I will ask a question after that. After your explanation, I have a
Okay.
question.
Okay. So, Emmanuel, so in case if you just have great troubles with the networks, so you feel that it's so upset and depressive to find these networks and there is no success at all, finding data sets is not the focus and not the main purpose of our course. So in this case, just let me know that you have problems with the networks. I can help. So we have I have several networks, so I can just send you a data set with networks that are okay, and even I can send you a code how to import them, because I don't think that we should. Well, we tried to use this, but if we have great problems, we better get some help, and then we focus on the most important things. Okay, I see. Okay. I can't promise that I will do it today, but maybe during this week I will send you this data set. Uh, yeah, this data and code. Okay, that's great, because the main focus of our course is more about algorithm and general scheme of these games and uncertainties and real data even, but not from the uh, point of view that we just downloaded, but some kind of properties of this real data and so on. So downloading data set is not in our focus for this course. Okay, okay. But Emmanuel, well, you might think about algorithm. So, uh, how will you use this data set in your algorithm? So you can create an algorithm for Nash equilibrium, for informational structure that we have discussed today. That you will be ready to implement this database, to include this database into your algorithm, because okay, yeah. Okay, nice. Okay. Ishita, so what was your
So I have a question about the data sets.
Mhm.
So basically, according to our task, according to our homeworks, so we need only the nodes and edges, right? Because we have some extra details here in the
Yeah,
data, these data sets like
yeah,
length and flow and
yeah.
some other weights, right? I think we don't need other data, right? We just need the nodes and the edges, right?
Uh, yeah. Weights are useful for us. So if we want
Yeah,
to,
weights are, yeah, but the other data like
yeah,
power, speed, stuff like that,
yeah.
we don't need, right?
I think we don't need them. Yeah. If you
Yeah,
want to
basically we
create
need
very
nodes and the edges and weights, right?
yeah, yeah. If you want to create a very complicated model, you can include all these, but it's not required. So
But
it's up.
no, I will start with the basic one because I need to
Yeah, I understand. It's
study
okay.
the ones and
Yeah. That's okay. Okay.
okay. I think by next week I will implement some code and I will
Yeah,
show
that's
you the
nice.
results.
Yeah. Nash equilibrium.
I'm so sorry because I was absent in last 2 weeks and last 3 weeks actually.
Yeah.
I got COVID and I was sick and I had many problems.
Yeah. That's okay. That's okay. We are all humans. We are here.
Yeah,
So, yeah.
but
Don't be.
I think we have time, so I will be able to complete it.
Yeah. Okay. That's nice. Yes. Yeah. That's okay.
Okay,
Okay.
thank you,
That's
thank
good.
you.
Okay. Okay, we have about 10 or 15 minutes before the finish. Well, because before our lecture will be over here, and we will meet maybe next week. But I'm not sure about next week because we will have like break between model 3
Yeah,
and model.
we have some students have their exams and the session time is on.
Yeah. So maybe next week will be skipped, but then after we start the fourth model, we will meet and discuss our progress. Okay, yeah, that's a good plan. Okay, nice. But so before this break for several weeks, can discuss. So if you have any questions and ideas, maybe if you want, I can just check. Well, I can describe some topics more precisely and more clearly, but 30 minutes. Okay. What we can have? Ilya, have you developed? Have you finished your work? Ilya?
I don't think I will
Not
be
yet.
ready.
Oh, okay. Okay. Yeah. I just checked. Okay. Great. So we have 30 minutes before. I'm here. I'm online. So if you have questions, you can ask me. If no, we just wait for the end of this lecture and then say bye-bye. And I will wish you success with your exams, and we'll meet at next module.
Thank you.
Okay, so it's time to finish our lecture. I wish you good luck and see you next time, next in next model. Bye.